What if the life we know, based on sunlight, oxygen, and moderate temperatures, is just one small part of a much larger cosmic picture? What if our planet itself is teeming with bizarre organisms that thrive in conditions that would instantly kill any human, challenging our very definition of what it means to be alive? In this video, we're diving into 10 astonishing places on Earth where life exists against all odds, exploring the incredible adaptations, the bizarre survival strategies, and the mind-bending realities of extremophiles. From superheated vents on the ocean floor to radioactive deserts and deep underground ecosystems, get ready to have your perspective on life's resilience completely revolutionized. And trust me, the number one discovery on this list is so profound, its implications will make you question if life truly originated on the surface of our planet at all. You're about to explore the fascinating intersection of biology, geology, and the unknown, pushing the boundaries of what we deem biologically possible. Can you imagine a creature that can survive in a radioactive environment with a radiation dose 1,000 times higher than what would kill a human? Stick around, because I'm going to reveal the bizarre truth about a microbe that thrives in the deadliest places. Before we explore these incredible life forms, do me a quick favor, hit that like button, share this with a friend who loves cosmic mysteries, and if you haven't already, subscribe and ring that notification bell so you don't miss out on more mind-bending content from 360 World. And I want to hear from you. Which of these extreme environments do you find the most fascinating? Drop your thoughts in the comments below. 10. Deep sea hydrothermal vents, the ocean's hot springs. What if entire ecosystems teeming with life exist in the complete absence of sunlight, clustered around superheated vents on the ocean floor that spew toxic, mineral-rich fluids? Imagine a world where the base of the food chain is not photosynthesis, but geosynthesis, a bizarre process where microbes use chemical energy from the earth itself to create food. This isn't just an underwater anomaly. Deep-sea hydrothermal vents are oases of life in the ocean's abyss, supporting a diverse community of organisms that have evolved to thrive in extreme conditions of heat, pressure, and chemical toxicity, defying all traditional understanding of life. How does life survive in such extreme conditions? Hydrothermal vents, often called black smokers, are fissures on the seafloor that release geothermally heated water. The fluid, superheated by magma beneath the Earth's crust, is rich in chemicals like hydrogen sulfide, which are toxic to most life forms. However, around these vents, a unique food chain thrives. Microbes, known as archaea and bacteria, use chemosynthesis to convert these toxic chemicals into energy, forming the base of the food chain. These microbes support a diverse community of animals, including giant tube worms, blind shrimp, and unique species of crabs and clams that have adapted to live in the scalding, high-pressure environment. It's a testament to the incredible resilience of life, an underwater oasis of life thriving in a toxic environment. What other hidden ecosystems are waiting to be discovered in the depths? Let me know in the comments. Embrace yourself, because our next life form is a master of extreme heat. 9. Yellowstone's hot springs, life in boiling water. What if the vibrant, colorful hot springs of Yellowstone National Park, with their scalding temperatures and high acidity, are not just beautiful, but are home to unique and ancient life forms? Imagine a world where microbes can thrive in boiling water, defying all traditional understanding of what it means to be alive. This isn't just a hot spring. Yellowstone's hot springs are a living laboratory of extremophiles, supporting a diverse community of microorganisms that have evolved to thrive in extreme conditions of heat and acidity. How does life survive in boiling water? The hot springs of Yellowstone are home to a diverse community of microorganisms known as thermophiles, heat lovers. These microbes can thrive in temperatures as high as 122 degrees Celsius, 252 degrees Fahrenheit, far above the boiling point of water at sea level. The microbes are so well adapted to the extreme heat that they can't survive in cooler temperatures. They have a unique metabolism that allows them to thrive in these extreme conditions, using chemosynthesis to convert chemicals from the springs into energy. The vibrant, colorful hot springs are a testament to the incredible resilience of life. They are a living laboratory of extremophiles, supporting a diverse community of microorganisms that have evolved to thrive in extreme conditions of heat and acidity. Life in boiling water. What other incredible life forms are hiding in the hottest places on Earth? Don't go anywhere, because our next life form is a master of extreme cold. 8. Antarctic dry valleys. Life in the frozen desert. Have you ever wondered what lives in the coldest, driest, and most extreme desert on Earth? A place where no plants or animals can survive on the surface? Imagine a world of ancient frozen deserts, a place where microbes can thrive in a unique and bizarre environment of extreme cold and low humidity. This isn't just a desert. Antarctic dry valleys are a living laboratory of extremophiles, supporting a diverse community of microorganisms that have evolved to thrive in extreme conditions of cold and desiccation. How does life survive in the coldest place on Earth? The Antarctic dry valleys are the coldest and driest desert on Earth. The valleys are so cold and dry that no plants or animals can survive on the surface. However, beneath the surface, in the cracks and pores of the rocks, a unique community of microorganisms thrives. These microbes, known as psychrophiles, cold lovers, can survive in temperatures as low as -20 degrees Celsius, 4 degrees Fahrenheit. The microbes are so well adapted to the extreme cold that they can't survive in warmer temperatures. They have a unique metabolism that allows them to thrive in these extreme conditions, using chemosynthesis to convert chemicals from the rocks into energy. Life in a frozen desert. What other incredible life forms are hiding in the coldest places on Earth? Up next, a bizarre microbe that thrives in the deadliest places. 7. Chernobyl. Life in a radioactive hotspot. What if the most dangerous radioactive place on Earth, a silent ghost town that was consumed by a nuclear disaster, is not a barren wasteland, but is home to a unique and bizarre life form? Imagine a world where a microbe can thrive in a radioactive environment, a place where no human can survive for long. This isn't just a wasteland. Chernobyl is a living laboratory of extremophiles, supporting a diverse community of microorganisms that have evolved to thrive in extreme conditions of radiation. How does life survive in a radioactive environment? The Chernobyl exclusion zone is the most dangerous. Radioactive place on Earth. The zone was established after the catastrophic explosion of Reactor 4 on April 26, 1986, which released massive amounts of radioactive material into the atmosphere. However, in the highly radioactive sarcophagus surrounding the destroyed reactor, a unique community of microorganisms thrives. These microbes, known as radiotrophs, can use the energy from ionizing radiation to produce food. The microbes have a unique metabolism that allows them to thrive in these extreme conditions, using chemosynthesis to convert radiation into energy. The discovery of these microbes in a radioactive hotspot is a testament to the incredible resilience of life. Life in a radioactive hotspot. What other incredible life forms are hiding in the deadliest places on Earth? Don't go anywhere, because our next life form is a master of extreme pressure. 6. Mariana Trench, the deepest abyss. Have you ever wondered what lives in the deepest, darkest, and most high-pressure place on Earth? A place where no human can survive without a specialized submersible. Imagine a world of ancient, isolated abysses, a place where microbes can thrive in a unique and bizarre environment of extreme pressure and low temperature. This isn't just an abyss. The Mariana Trench is a living laboratory of extremophiles, supporting a diverse community of microorganisms that have evolved to thrive in extreme conditions of pressure and darkness. How does life survive in the deepest abyss? The Mariana Trench is the deepest, darkest, and most high-pressure place on Earth. The pressure at the bottom of the trench is over 1,000 times that of the surface, a pressure that would crush any human. However, in the cracks and pores of the rocks, a unique community of microorganisms thrives. These microbes, known as piezophiles, pressure lovers, can survive in these extreme conditions, using chemosynthesis to convert chemicals from the rocks into energy. The microbes are so well adapted to the extreme pressure that they can't survive in lower pressures. They have a unique metabolism that allows them to thrive in these extreme conditions, using chemosynthesis to convert chemicals from the rocks into energy. Life in the deepest abyss. What other incredible life forms are hiding in the darkest corners of the planet? Coming up next, a bizarre microbe that survives without oxygen for millions of years. 5. Deep biosphere microbes. Life without light or oxygen. What if the deepest parts of Earth's crust, miles beneath the surface and cut off from light and oxygen, harbor vast ecosystems of ancient microbes that have been living in isolation for millions of years? Imagine organisms thriving in extreme conditions of heat and pressure, sustained by chemical reactions, representing a hidden world of ancient life that defies our conventional understanding of biology. This isn't just underground. Deep biosphere microbes represent a massive, largely unexplored, dark matter of life on Earth, continuously baffling scientists with their unique survival strategies and their incredible ancient lineages. How do these microbes survive in such extreme isolation? The deep biosphere is a vast interconnected ecosystem found in rocks, sediments, and fluids miles beneath Earth's surface and the seafloor. It's estimated to contain a massive amount of microbial life, possibly more than all life on the surface. These microbes survive in conditions of extreme heat, pressure, and complete absence of light or free oxygen, deriving energy from chemical reactions with surrounding minerals. Some lineages have been isolated from deep sediments and are estimated to have evolved in isolation for tens to hundreds of millions of years. Their unique metabolic pathways, incredible longevity, and resilience challenge fundamental assumptions about the limits of life and carbon cycling on Earth. While not waking up in the same sense as permafrost microbes, the discovery and ongoing study of these ancient, isolated deep Earth organisms continue to reveal a hidden, bizarre, and profoundly mysterious microbial world, life thriving miles beneath us, in conditions no one expected. What other hidden ecosystems might exist deep within our planet? Don't go anywhere, because our next discovery is an extreme survivor found in ice cores. 4. Subglacial lake microbes. Antarctic ice mysteries. Have you ever wondered what lives beneath miles of Antarctic ice, isolated from the surface world for millions of years in vast dark lakes? Imagine discovering unique, ancient bacteria and archaea thriving in the frigid, high-pressure environment of subglacial lakes, cut off from atmospheric oxygen and sunlight for unfathomable periods. This isn't just frozen water. Subglacial lake microbes are ancient organisms found in places like Lake Vostok, representing a truly isolated evolutionary lineage, offering tantalizing clues about life in extreme extraterrestrial environments and defying typical survival limits. How did life survive in such extreme isolation? Subglacial lakes are vast bodies of liquid water trapped beneath thick ice sheets, particularly in Antarctica. Lake Vostok, one of the largest, has been isolated beneath 3.7 kilometers, 2.3 miles of ice for over 15 million years. Scientific drilling into these lakes has revealed diverse and active microbial ecosystems, comprising unique bacteria and archaea that are genetically distinct from surface life. These organisms survive in conditions of extreme cold, high pressure, darkness, and low nutrient availability, likely deriving energy from chemical reactions with the surrounding rocks and water. Their ability to thrive in such prolonged isolation pushes the boundaries of our understanding of resilience and adaptation. While not actively waking up in a dangerous sense, the study of these ancient, uniquely adapted microbes helps us understand the potential for life in extreme environments, including on other planets, ancient life trapped beneath miles of ice. What secrets of survival do these isolated ecosystems hold? Now, prepare for the top 3, which delve into the most profound and globally impactful reawakenings. The next one is about bacteria that resist modern medicine. 3. Antibiotic-resistant bacteria from deep ice. The superbug archive. Could ancient bacteria, frozen for tens of thousands of years in deep ice, reawaken and carry genes for antibiotic resistance, presenting a terrifying new challenge to modern medicine? Imagine microbes from the Ice Age, never exposed to modern antibiotics, suddenly emerging with innate abilities to withstand our most powerful drugs, threatening to unleash a new generation of superbugs. This isn't just speculation. Antibiotic-resistant bacteria from deep ice have been discovered and revived by scientists, confirming that ancient environments hold a dangerous archive of resistance genes that could complicate future public health efforts. Do ancient ice sheets hold the blueprint for future superbugs? Scientists have extracted and revived bacteria from ancient permafrost and deep ice cores, for example, from glaciers or the Greenland ice sheet dating back tens of thousands of years. Analysis of these revived microbes and the genetic material found in the ice has revealed the presence of genes for antibiotic resistance. Crucially, these bacteria existed long before the widespread use of modern antibiotics, suggesting that antibiotic resistance is a natural, ancient phenomenon, not solely a product of modern medicine's overuse of drugs. The concern is that as these ancient, resistant bacteria re-enter modern ecosystems, they could exchange genes with contemporary bacteria, potentially accelerating the evolution of new superbugs for which we have no effective treatments, posing a significant future public health crisis. Ice Age superbugs, awakening with ancient defenses. What new threats are emerging from Earth's frozen past? Up next, a terrifying discovery from ancient human remains. 2. Mummified pathogens. The unseen threats in ancient graves. What if the perfectly preserved remains of ancient humans, buried in permafrost or dry environments, hold dormant pathogens that could reawaken and unleash diseases thought long extinct? Imagine mummies from the Arctic or arid deserts, holding the genetic material of ancient plagues, waiting for the right conditions to stir. This isn't just archaeology. Mummified pathogens, found in ancient human remains, represent a chilling archive of past diseases, prompting scientists to carefully extract and study them for insights, but also raising concerns about accidental re-release of forgotten scourges. Could ancient diseases rise again from graves? Scientists have successfully extracted and sequenced genetic material from pathogens found in mummified remains. Examples include fragments of the 1918 Spanish flu virus from permafrost-preserved bodies, smallpox virus from ancient burials, and even bubonic plague bacteria from medieval graves. While the goal is to study the evolution and virulence of these historical pathogens to better prepare for future outbreaks, the process itself and the potential for accidental re-exposure or reanimation raises ethical and safety concerns. The preservation of these deadly ghosts in ancient graves serves as a stark reminder that death is not always the end for microbes, and that digging into the past can have unforeseen consequences for the future. Ancient plagues preserved in human remains. What horrifying diseases could still be lurking in forgotten graves? And now for the number one ultimate awakening, something that fundamentally questions our planet's deep history and future. This is the one that changes everything. 1. The Siberian traps microbes, architects of mass extinction? What if massive eruptions billions of years ago unleashed dormant microbes from deep within the Earth, triggering catastrophic environmental changes that led to the largest mass extinction events in Earth's history? Imagine ancient bacteria, once buried, being brought to the surface by colossal volcanic events, fundamentally altering the atmosphere and oceans, and wiping out nearly all life on the planet. This isn't just geology. The Siberian traps microbes and their potential role in the Permian-Triassic extinction, the Great Dying, suggest a terrifying truth: that ancient, reawakened microbes interacting with geological forces could be the ultimate architects of planetary destruction, a chilling precedent for our future. Could ancient microbes truly have caused mass extinctions? The Permian-Triassic extinction event, around 252 million years ago, was the most severe extinction in Earth's history, wiping out about 96% of all marine species and 70% of terrestrial vertebrate species. The event is strongly linked to massive volcanic eruptions in the Siberian Traps. Recent research suggests that these eruptions unleashed vast amounts of nickel, which then acted as a super-fertilizer for specific ancient microbes, like Methanosarcina, in the oceans. This microbial bloom rapidly produced massive amounts of methane, a potent greenhouse gas, leading to extreme global warming, ocean acidification, and widespread anoxia, lack of oxygen. This hypothesis suggests that while volcanism was the trigger, it was the reawakening and proliferation of ancient dormant microbes, given the right conditions, that amplified the environmental catastrophe to an extinction-level event. It implies that ancient microbes disturbed by geological forces can act as terrifying engines of planetary transformation and destruction, a chilling parallel for any future reawakenings. Ancient microbes orchestrating global extinction. It's the ultimate chilling history lesson, isn't it? If these ancient microbes awakening left you speechless, then you absolutely have to check out our next video right here, where we explore even more bizarre scientific phenomena that defy current understanding. You won't want to miss it. And remember, if you only scrolled to the end of this video, you missed out on the terrifying reality of anthrax outbreaks from melting permafrost and the chilling existence of zombie viruses. Definitely go back and watch those parts. Before you go, hit that like button one last time. Share this video with anyone who's fascinated by the hidden dangers of our world. And if you haven't subscribed yet, what are you waiting for? Join the 360 World community, and let's keep exploring the planet's most profound and unsettling secrets together. Until next time, stay curious, stay questioning, and keep an eye on what's thawing.